Okay, so let's start by looking at all of the different laws that we've got, and it might help if you want to copy these down. So first of all, the multiplication law is one of the more basic ones. It simply states that if you are multiplying two terms together that have the same base, then you simply add the indices or the powers together. Now, the reason for this is actually relatively simple. If we pick some quite nice numbers, so let's say we've got something like x to the power of 3, and we're timesing that by an x squared. Now, we can just write this slightly differently. Of course, we know that x cubed, or x to the power of 3, simply means x times x times x. And then it says that we're multiplying that by this x squared, which is an x times by another x. So now if you look at that, we've got 5 x's being multiplied together. But what's a way that we can write that slightly simpler? Well, of course, it's just x to the power of 5. But as mathematicians, we always want the quickest way to find that answer. So how do we go from the first line of working straight to the last and skipping out that middle step? Well, we can quite clearly see that all that we would need to do is take the 3 that we've got here, add the 2 onto it, and it will give us the 5. But of course, this law only works when you've got the same bases. And what I mean by a base is this part here, this x was the base each time. So we had an x and an x as the two bases in the question, which meant that we could apply this law of indices. And that's going to be the same pattern for all the rest of them as well. Okay, the second one is essentially the inverse or the opposite of the first one. We've got our division law. And this simply states that if you are dividing two terms that have the same base, then you can simply subtract the indices or the powers. And again, let's look at quite a simple explanation for why that might work. So let's take two relatively simple terms. Let's use y's instead this time. So you might have something like y to the power of 4. And you might be dividing that by a y squared. Now, exactly the same as how we did the last one, I'm just going to write that out in a slightly different way. So y to the power of 4, we know is y times y times y times y. And the y squared that we've got on the bottom there, we know that that's simply y multiplied by another y. Now, you might remember from foundation maths or maths that you did a few years ago, if you've got the same thing on the top and the bottom of your fraction and you've got it as the factors being times together as we do here, you can simply cross out and simplify down anything that is the same top and bottom. So any factor pairs essentially. So we can see that we've got a y there and a y there. So that's one of our pairs that we can cancel out. I've got another y on the top, another one on the bottom. They can cancel out. But now there's no more on the bottom. So we can't cancel any more. So what we're left with is two y's being multiplied together on the top. And then we've got this 1 on the bottom, which of course just simplifies to this y squared. Okay, very common misconception is that you end up with 0 on the bottom there. But remember, if you divide anything by itself, like if you had 2 divided by 2, you'd always get 1, which is why when you do this y divided by y, you don't get 0, you get 1. Okay, and then the third one that we have got here is our power of 0 law. And essentially, this is probably the simplest one. Anything to the power of 0 is always going to equal 1. And there's a really interesting reason why. And if I show you that, if you understand it, it will really help you to remember it. And it actually links into one of the previous ones that we've already looked at. So for example, let's take something again. Let's go back to x's. So let's say that we've got something like x squared divided by x squared. So in other words, we're taking something and dividing it by itself. Now we know that when you divide anything by itself, you get 1. Like we said earlier, if you've got 10 divided by 10, that's 1. 5 divided by 5, that's always 1 as well. So x squared divided by x squared, that's going to be 1, 2. But another way of thinking about this is actually using the division law. So law number 2 that we just looked at. Now we said that if you're dividing and you've got the same base, you just need to subtract the 2 powers that you've got. So if I take this and I subtract my 2 powers, I'm going to have 2 take away 2, which is going to give me 0. So what we actually end up with here is this x to the power of 0 equals the 1 on the other side. And that will work with anything, any numbers or any algebraic terms that you try. Okay, the fourth one is a power raised to another power. So you can see here, the way I've written it is x to the power of n, and then that is all to the power of m afterwards. Now, whenever you have a power raised to a power like that, you simply multiply the two powers together. Okay, and again, there's a nice simple reason why, and it relates back to the first law of indices that we just looked at. So if we do this with some numbers, so let's say we've got something like an x cubed, and we're going to put that to the power of 2. Now, in simple terms, you just need to think, well, what does it actually mean to square something? Well, hopefully you know when you square something, it means to times it by itself. So this x cubed that I'm squaring here, all that means that I'm doing is taking my x cubed and timesing it by itself, timesing it by another x cubed. But then going back to the first law of indices, the multiplication one, if you're multiplying and you've got the same base, you add the two powers together, which will give us 3 plus 3, which is 6. But of course, we always want to try and skip that middle step if we can. So how do we go straight from the original question, where we had the 3 and the 2 here, and to the final answer where we have the 6? Well, of course, hopefully you can see if you take the 3 and multiply it by the 2, it will give you that 6. So that's our fourth law of indices. Power raised to a power, always going to multiply those together. Okay, all four of the ones that we've looked at so far do appear on the foundation paper. They are foundation level content, but they will still be useful on the higher tier paper. The next one that we've got does technically appear on the foundation paper as well sometimes, although it comes up a lot less often. It's one of the more challenging ones. And then the sixth one that we're going to look at, the final one, only appears on the higher tier paper. So let's start with number 5. This is where we've got a negative indice. Essentially, whenever you see a negative indice, you just need to remember to do 1 over. And there's a couple of reasons why. You can look at patterns and things like that. I'm not going to go into the full details of it now. But essentially, just remember, whenever you've got a negative indice, you're going to do 1 over straight away. So what I mean by that is, and I'm going to do it all with numbers this time, I'm not even going to use any algebraic terms. Let's say you've got something like 3 to the power of minus 2. Okay, so based on what I just said, whenever you see that negative power there, so I've got a negative 2, I need to do 1 over. And then all that you do is actually ignore the minus sign. So if I ignore the minus sign in the question, it would be a 3 squared that I'm left with. You essentially get rid of the minus sign. And then you just simplify from there. So 3 squared we know is 9. So I end up with 1 over 9 like that. Okay, that's essentially how it works. Now for the final one, the trickiest one of them all. Again, there are logical reasons why, a few different reasons, in fact, why this method works. But again, I'm not going to go into the details. You just need to remember the steps for this one. Essentially, whatever you have in the denominator of this fraction, so you can see that I've got this x to the power of n over m. I've got that fraction in my power, in my index. Whatever you have on the bottom of the fraction, that's the root that you're going to take, and you're going to do that first. And then whatever you have in the numerator of that fraction, whatever's on the top, you're then going to raise it to that power. And the way I like to think about it is the number that's on the top, the numerator is up high, and you're going to be raising it up high, raising it to that power. That might sound a little bit confusing, so let's have a look at how we might do this with some numbers. So let's say, for example, we've got something like this, so maybe 8 to the power of 2/3. Okay, so based on what I just said, we need to first of all look at our denominator, which is a 3. And we said that that's the root that we're going to take. So I'm going to put a root sign. I need to take the third root, and I do it of the base number, which is the 8. But then we said after that, we then need to raise it up to the power of whatever's on the top of the fraction, whatever the numerator is, which is a 2. And then we can just work out the answer from here step by step. So the cube root of 8, what times itself 3 times equals 8? That's of course 2. But then of course I need to put it to that power afterwards. So I worked out the bracket first, and then I'm now squaring it because I had a 2 on the top of the fraction. So final answer is going to give me a 4 there.